Good day, grade 8. Welcome back. We are doing video 4, where we work with multiples and factors. The one thing that stands out here is that we need to know our tables, and if we do not know this, then we're going to find it extremely difficult to work through this chapter. Remember, this resource is copyright protected, so do not crop any of the credits away from the creator, who is Ricardo Alroy Wissing. Let's start off with factors. What is a factor? Here we must remember that a factor is a number that divides into another number. Exactly. No remainders. Right? So if we talk about the number 12, what are the factors of 12? The factors of 12 is 1, 2, 3, 4, 6, and 12. These are numbers that can divide into 12 without a remainder. So you will always see that there's a pair. So 1 and 12 goes together, the 2 and the 6 goes together, and 3 and 4 goes together. We move on to the next one. What is a prime number? A prime number is a number that is only divisible by itself and by 1. It's got no other factors. Can you name all the prime numbers up to 100? All the prime numbers that you find. Let's see if you can assist me to show all the prime numbers. So 1 is not a prime number because it doesn't have two factors, it's only 1. So the first prime number that we have is 2. So now we eliminate everything that 2 can divide into. So that means all the even numbers is immediately eliminated because 2 is the first prime number. So the next number that was not eliminated is 3. So we eliminate all the factors of 3. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51. So everything that 3 can divide into. I just want to show something quickly if I eliminate the other numbers. So you will see the patterns that unfold when I work with 3's. So it will be all these numbers that follows this row. Then we have 30, 39, 48, 57, 66, 75, 84, 93, and you can see now this follows a pattern of skip 2 numbers and the third number. So skip 2 numbers and the third number. So 60, 69, 78, 87, 96. Then skip 2 numbers and go to the third number. So these are all the factors of 3 that is eliminated. So the next number that is not eliminated is then the next prime number. So all the 5's are eliminated, all the 10's are eliminated. That gives me all the factors, all the numbers that 5 can divide into. So now we go to 7. Here's the next prime number. So 7, 14, 21, 28, 35, 42, 49, then 56. And so I can eliminate my prime numbers. So by virtue of elimination, I can do these prime numbers easily now. So I can see all the factors where 11 will divide into will be eliminated. Then my next prime number is 13. So then I go 26, 20, 39, etc. and I can go on. Can you find all the other numbers now that will be prime numbers if these numbers are taken out of the equation? What remains? After you found all the prime numbers, the main ones that we will be working with is 2, 3, 5, 7, 11, 13, 17 and 19. Those are the main ones that we will work with, but it is not limited to that as 23, 29, 31, 37. They are also prime numbers that could potentially be used, but the main ones that we will work with is 2, 3, 5, 7, 11, 13, 17 and 19. Right? Now we know how to identify a prime number. It is a number that has only two factors, 1 and itself. Now what is prime factors? When I am asked to write a number in prime base or in prime factors, I list the prime numbers that must be multiplied to give me the product of that number. For example, if they speak of a number 6, the prime numbers that will give me 6 is 2 multiplied by 3. If they ask me what is the prime factors of 12, 12 will be 4 times 3, but remember 4 is not a prime number. So if I have to write 4 in prime numbers, it will be 2 times 2. Therefore 12 in prime factors will be 2 times 2 times 3. This will prove vital when I work with exponents later on. If I can prime factorize, then working with exponents will become very elementary. Now, when we prime factorize a number, remember there's two methods that you were taught at primary school. One was the tree method and the other one was the ladder method. So how did this work? We firstly list the number 12 and we look at the smallest prime number that can divide into 12. It's an even number, so 2 can divide in there. 2 goes into 12, 6 remains. Then 2 goes into 6 3 times. Then 3 goes into 3 once, and only once I get to that point, I stop my operation. So when I look at my ladder method, I say 12 is an even number, so the smallest prime number is 2. 2 goes into 12 6 times. Once again an even number, so 2 can divide into 6 as well. So 2 goes into 6 3 times. So now it is 3. 2 can no longer divide into 3, so I need to go to the next prime number, which is 3. So 3 goes into 3 once, so the prime factors of 12 is 2 times 2 times 3. Sometimes the teacher also have the numbers on the other side of the line. So I'm going to illustrate it quickly to you. So 12 needs to be prime factorized, so I say it's an even number, therefore 2 can go into 12, and that is 6 times. Once again I have an even number, so 2 can divide into 6 3 times. Now, no longer even number, so I must go to the next prime number, which is 3. 3 goes into 3 once, and only then do I conclude my operation. So my multiplication for 12 is 2 times 2 times 3. Those are my prime. Now prime factors being 2 times 2 times 3 can be written because there's 2 2's. I raise a 2 to the power of 2 multiplied by 3. Right, so now they ask us, what is the highest common factor of 12 and 30? Let's have a look at how we can answer the above question. There are two methods to find this. Method 1. Find all the factors of 12. So the factors of 12 is 1, 2, 3, 4, 6, and 12. Find all the factors of 30. 1, 2, 3, 5, 6, 10, 15 and 30. The ones that are common is 2, is 3, is 6. But the highest common factor we refer to is 6. Alternatively, we can list all the prime factors of 12, which is 2 times 2 times 3, and list all the prime factors of 30. Now we know 30 is 3 multiplied by 10, but the prime factors of 10 is 2 times 5. So now we look at what is common. So I take 1 out of the group of 2's, 1 out of the group of 3's. So my highest common factor is 2 multiplied by 3 is equal to 6. Then there is a third method, and I particularly like this one. I list all the prime factors of 12. I list all the prime factors of 30, but in this instance, each column can only facilitate a specific number. So if the first number is a 2, I cannot put a 3 or a 5 or 7 in here. I can only put a 2 underneath a 2. Then underneath the 3's can only be 3. And then there was no 5's in the top one, but there is a 5 in the bottom number. So my prime factors 2 times 3 times 5 is then my prime factors. Now to identify the highest common factor, I take out all the ones that are common in both the numbers. So my highest common factor is equal to 2 multiplied by 3. And that answer I write down as equal to 6. I hope that this method, especially if your teacher has taught this to you, that you can also use this. The next one we will work with is composite numbers. A composite number is any number that have more than 2 factors. Remember, a prime number has got only 2 factors, 1 and himself. So composite number is any number that have more than 2 factors. So if I take a number, for example, 4. 4, the factors for 4 is 1, 2, and 4. So that will be a composite number. Let's look at, again, multiples. What is multiples? Multiples is when I multiply a number of times. For example, 8, 16, 24 are all multiples of 8. Where I multiplied 8 with 1, 8 with 2, 8 with 3. What is the lowest common multiple of 4 and 7? And here we will list all the multiples of 4 and all the multiples of 7 until we have a common multiple. So how do we do this? We say 4, 8, 12, 16, 20, 24, 28, 32, and this can go on and on. The multiples of 7 is 7, 14, 21, 28, 35. And the first common multiple here would be 28. So I list the lowest common multiple is 28. Now we briefly look at the homework and we get you ready for doing this. Trust you enjoyed the lesson. Press pause before you reveal the answers. Here are the answers. Trust that you got them. And question 5's answers are as follows. Thank you for watching this video. I will see you in the next video.